Oh, it's already after 5. All right, let's go a little further. What about projectile problem? Let's go to chapter 3. Let's go to chapter 3. Anybody still? 10 people signed up for this. It kind of bugs me. I mean, you're here, you guys are here, so I don't begrudge that. I picked it because so many people said they were going to be here. All right. Projectile motion. Problems. Okay. All these are calculus. Okay. This says it's was moving with constant velocity. Right. That one gave us problems, right? Okay. Let's try this one. Okay, so we're flying horizontally. Flying horizontally. And we have a v sub x equal to 64.0 meters per second. And we'll call this the plus direction. And we have a height. Y sub 0 equals 90 meters. At what? So we want to hit the ground. So this is one where they tell us the range. And then we have to say, once we calculate, that's so weird. Why doesn't it? Okay. Horizontal distance. Okay, so we want to hit, so we're going to say we're here, and we can call that x sub 0 equal to 0. And then this is going to be x of impact, or the range. And we're going to call this also y equals 0. So we have that happy circumstance. And so basically, oh, I see. This is straightforward. Remember, y gets you time. So we know our v sub x. So v sub x times t will get us our range. But t is unknown. But they told us we're flying over the Earth, for example. They tell us that there's no air resistance, so A is going to equal G, which is equal to negative 9.8 meters per second squared. So we want to know, first we need T. So T comes from Y. So we need Y equals Y sub 0 plus v sub 0 y plus 1/2 at squared. We also know that v sub 0 y, we infer that because it said dropped, and so is equal to 0.00 meters per second. And y equals 0, so we want to solve for the time. So let's see. 1/2 at squared equals y minus y sub 0, and if you like, minus v sub 0 y times t, but we're going to say that's 0. Okay, so then t squared equals 2 times y minus y sub 0 over a, and then t equals the square root of that, and that equals 0 minus 90 over minus 9.8, and that is to the half power. So that's going to get us what? About 9. So it's going to be about 3 seconds, right? I think it's 3 seconds. Notice the minus signs cancel out. So 90, enter, 9.8, divide. And then if I get the square root, it's basically 3.03 seconds. So then I plug it back into here. So the range equals 64.0 meters per second times 3.03. So almost about 200 meters, 195 meters. I leave it to you. So when the pilot sees that they're 195 meters away, they release. Okay, so almost an hour. I usually only do this for an hour, but let's see. Let's do a circular problem, huh? I'm going to watch the doodle poll. Maybe I better tell. Everybody wanted to do one on Tuesday. I got a lot of responses for Tuesday. Okay. Copy. All right, let's see. Let's make it a little smaller. The Earth's orbit around the sun. Oof, that didn't copy very well, did it? All right. Our Earth's sun equals 1.50 times 10 to the 8th kilometers, which is 1.50 times 10 to the 11th meters. And we assume that t equals 365 days. Oops. Which is 24 hours in a day and 60 minutes per hour, 60 seconds per hour, minute. And so that means that days, hours, minutes. So that equals 365, enter, 24 times, 60 times, 60 times. Wow. 3.15 times 10 to the 31 million seconds, huh? In a year. I don't know. Do I believe that? 10 squared, 10 to the 1 is 10 to the third. Maybe. 365, enter. 24 times 60 times 60 times. Yep. Okay. What is the magnitude of the orbital velocity of the Earth in meters per second? So that is if I have going around like this. So I have R, Earth, Sun, and I want to know what V is. Well, I want to know the magnitude. Okay. So this one here, this one here, you might be fooled. I don't think you actually need to use V squared over R, because we know that speed equals distance over time. And so distance is going to be one circumference. So it's going to be 2 pi radius of the Earth around the sun divided by the period. So that's going to be 2 pi times 1.50 times 10 to the 11th over 3.15 times 10 to the 7th. How fast are we cooking along in space, huh? If you're at the equator, you're going at 1,000 miles an hour. But way out there, where's pi? Oh, there it is. Times 1.5 E4 times, no, that's E11. 1 E7 times, big number. 3.15 E7 divide, and I get 2.99 times 10 to the 4th meters per second. So that's 1, 2, 3, 4. 1, 2, 3, 4. Ooh, 29500. 2900. 29,000 meters per second, huh? Not bad. That's damn fast, huh? Okay, so gosh, all we have to do is substitute in the radius of Mercury. That wasn't very hard. We need a little more challenging, huh? Hypergravity. Ooh. I wonder what that means. Let's see. Relative velocity. Motion in a circle. Pilot blackout. Hmm. 5.5 Gs. Let's see. All right, I've done this problem before. Let's see if I can remember. 0.25. So it's in this area that it's critical. Is the pilot really, once you're in these places here and here, you're not really feeling much. It's right here where you're doing, when you're changing directions. So we have a, ooh, let's try that color. That's R equals to 280 meters. So we have A equals V squared over R. Now, do we have to take into account the Earth? Well, let's say, if you were in a test and you weren't sure if you should take advantage of the Earth or not, well, let's do this. Let's just say that oh yeah, right. The Earth would matter. Okay, so it's 5.5 Gs. So when he's at the very bottom, or she's at the very bottom, doesn't say if it's a man or a woman, they're going to feel 1 G from the Earth. So, you feel Earth pulls you down, but if you're not falling, your chair is pushing up at you with 1 G. So we need to know to add it. This is the key to this problem. We have to have an additional 4.5 G. And then that, so what is that? What does G mean? Well, that's a way of expressing forces as multiples of the Earth's acceleration. So that means that in that airplane, I would black out when I would feel 4.5 times what I weigh extra, or 5.5 times what I weigh. Excuse me. So that comes from the acceleration of gravity. So that would be 4.5 G times 9.8 meters per second squared per G. So we're just going to call that, would make that a 10. So that's 45. Wow. Right? 45 meters per second squared. And so we know our radius. So we need to solve. We need to solve for V equals A times R. And it's pretty damn fast, it looks like to me, although we have to take the square root of it. So that's going to equal 45 meters per second squared times 280 meters. A half. The Lakers started at 5:30 or 6. 45 enter 280 times. And so, square root. 112 meters per second. But that's still pretty respectable speed. No, I don't feel like converting it. All right. Let me check the solution. I'm going to check to see that I did it right. Chapter 3, 3.25. 3.25. Yeah, this is a little bit different. Let's see. So um, they tested. They used 5.5 Gs, which is wrong. But that just means mastering would give you a hard time. Whereas I would take, I guess, either one. I might give extra credit if somebody subtracted, because it shows here he's in a downward dive. So the force of gravity comes into play, and even if he's really high in the air, so it would still be around. So that plugging in 5.5 G when you're not in outer space, or if you'd have to be in a horizontal, like flying in a circle, sort of. But if you're doing a dive and pulling out of the dive, then you have to add in gravity. Okay, so anyways, I'm shot. I'm pretty tired right now. I think this was being recorded. Yes. So let me I don't know how big of a file this is going to be. We'll find out in a minute. And if it's really big, I'll see if I can make it bigger. I mean, smaller, of course. Still didn't upload. That's a bummer. All right. I need to get that directory open. I am tired. I was doing. Oh, that's not so bad. And wait a minute. How can the PowerPoint be smaller than the? That never happens. Oh well. Oops, can't. I have to change it. Everyone. All right. There you go. All right, guys. If guys, be nice if you guys would have asked me for particular problems, but I mean, hopefully that you found that useful. In general, you could email me problems to do, and I could request problems, and then I could record myself and post them. But wow, hour and a half, so I'm pretty tired. Does anybody have any short questions? Oh no, I forgot to write this back to Axel, but I sent out an announcement anyway. Anybody has some here? Let's see, Eduardo. Yeah, okay, there you go. I am Eduardo. Let me see. Anybody else? Raymond. Okay. All right. So it doesn't seem like anybody has any questions. So I am going to say goodnight, and I will. Yeah. So wait a minute. Let's take a quick look at the doodle polls, and you'll see. Oh, there's some more answers here. Maybe. Let's see. You're here. I might as well. let you in. See, there was 10 people signed up for that one. Yeah, it looks like Tuesday at 5. Okay. So stay tuned. I can wait and see if anybody else votes. Okay. I don't even see where you guys are. I don't have my camera window showing up anymore. Ah, there it is. All right. This might look funky. I will see you all soon. Oh, no problem, Eduardo. I'm happy to do it. All right. Good night, guys. Good night, Jonah, Ulysses, Eduardo.